Hey everybody, my name's Chris and welcome back to Duluth Machine Works. Today, I'm going to try my hand at some Boilermaking and take this pile of steel and make it into the most important part of my wood-fired hot tub. So the next step here is going to be to lay out this tube sheet. It's going to be a circle cut out of this. This is some 1/4-inch plate steel. So I'm going to start by finding the center. So 7 1/4, 7 1/4. Let's go ahead and add some room for the layout mark. So the next thing I'm going to do here is we'll center punch the hole right at the center. So this is the plasma cutter circle guide, and basically it sits in that center drilled hole right here, and I'll hold the torch equidistant from that. So the way this works is the plasma cutter torch goes in the guide here, and you adjust it by positioning the center of the tip pretty much on the line that you want to cut. Okay, time for some more layout. So this plate's not really square at all, so I'm going to give myself a little extra here. We'll go, let's see, 7.5. Let's give it to 7.5. Way it should clean up all the way around there. That point fits perfectly. Should be set to the same length. These turned out pretty good. Most of the rust around the edge is cleaned as well. Should be ready to cut holes in here for the tubes. Now that I have the tube sheets roughed out, I need to cut all the holes for the fire tubes. Since I'm using 1.5-inch tubing for the fire tubes, the OD of this tubing is about 1 inch and 660 thousandths. Those holes need to be a fairly snug fit because I don't want to be filling a lot of gaps when I'm welding. My first plan was to use a hole saw. This is a 1 11/16" hole saw. Unfortunately, after the experience that I had when I was cutting out the holes for the air intake, I realized that my drill press actually needs a bigger motor. Right now it only has a 1/3 horsepower motor, which just isn't enough to turn these bigger hole saws, especially in steel. What I need to do is I need to figure out a more efficient way of cutting 20 holes, top and bottom, 10 holes in each. And I think the way to do that is going to be the plasma cutter. As you can see here, I'm terrible at freehand cutting with the plasma cutter. The circle guide that I have built to cut out these larger pieces works well for anything over about 6 inches in diameter, but for all of these smaller holes, it just can't get the accuracy that I need. I need these tubes to fit not snug, but at least a fairly close fit so that I don't have to fill any gaps when I'm welding. So now my task is to figure out a way to get this plasma cutter to go in a perfect circle. And I think I'm going to do that by making a circle template. Luckily, I have a machine in the shop that cuts perfect circles. I've got a piece of 1/4-inch aluminum plate here that'll be good for this template. What I'm going to do is I'm going to cut a circle in the center that's exactly the right size. and then this will have enough space that I can reach it with a C-clamp anywhere on the tube sheet and clamp it down while I'm cutting. Before I cut this hole, I need to figure out how much I need to allow for with the tip of the plasma cutter. Looking at this next to a piece of scrap that's the same size as the template, you can see that there's a distance between the actual cutting tip of the plasma cutter and the ceramic shield around it. What I need to do is I need to measure this and then figure out exactly how much to add to the diameter to make the hole the right size. Alright, the dimension that I ended up coming up with is about 310 thousandths. And that's in addition to the diameter of the tube. Before I take this over to the lathe, I do have one problem. Unfortunately, my lathe only has a 10-inch swing, which means that the largest diameter workpiece it can turn is 10 inches. And corner to corner, this is just barely larger than 10 inches. So what I need to do now is I need to snap these corners off so that they'll fit on the lathe. Wait a minute, this isn't a This Old Tony video. In my shop, we do things the old-fashioned way. Don't worry, you don't have to watch everything. It's not pretty, but it'll work. Now I just need to find the center roughly. This does not have to be accurate at all, but I just need to get it fairly close. Just do it with the Sharpie here. Alright, this is kind of an awkward setup here. I'm going to have to clamp this workpiece onto the faceplate. It's going to take a minute here. Need about 4 hands to do this. I'm just using that center mark to help keep things lined up. Nothing here is a critical dimension, so... I'm just using some scrap as setup blocks and then some strap clamps. Didn't quite hit that in the center. We can knock this around some though. Alright. Ugly, but it'll work. I'm going to get everything tightened down. This is definitely not a setup that I'm very proud of, but it does seem like it's going to hold. Really all I need to do is cut a hole gently with a hole saw and bore it out just a little bit larger, so hopefully it's not going to experience a whole lot of cutting forces, and I'm definitely not going to spin it fast. Alright, so I've taken a few measurements and done a little bit of math to figure out exactly what I need to cut. So my Firetube diameter is 1.655 inches, and it needs a buffer of about 0.310 inches on each side of that so that there's clearance for the torch head. We multiply this times 2 and add it to that tube diameter. That gives us a final dimension for the template of 2.275 inches. In my aluminum plate, the hole saw cut a 1.7 inch hole, so that means I need to increase the diameter of this hole by 0.575 inches. Since the lathe is cutting on the radius, I can divide that in half, and that gives me 0.2875. That's the depth of cut that I need to cut off on the lathe. I'm going to start here with the hole saw. I've got the lathe set as slow as it'll go, 30 RPM, and we're going to hope for the best. Hole saws work really well on the lathe because you can run the lathe a lot slower than you can run a drill press. I'm going to use a 3/4 inch boring bar with a high-speed steel tool bit. I've got a lot of stick out here because I don't want these clamps to come into contact with the carriage. I'm going to start by touching off, and then I'll take a really light cut here. There we go. Just did a quick sanity check here. I've got about 120 thousandths left to do. Check one last time to make sure. 20 thousandths left. That'll be our finish cut. Reversing the feed gears. And now let's do a spring pass out. That high-speed steel tool did a pretty good job of cleaning this up. It's actually a really good surface finish. I'm going to quickly deburr this with the Noga tool and then it'll be done. Well, that turned out pretty good. So I'm going to let y'all in on a secret. In the shop, I don't really do things in a linear fashion. In fact, most of this earlier part of the video was shot about 6 months ago. I had shot some video of laying out this hole pattern that'll go on the tube sheets, but unfortunately the audio wasn't very good, and I think it's better to just go ahead and redo it. Talking through what I'm doing here, what I need to do is I need to cut a series of holes into these tube sheets. I went ahead and laid this all out in CAD, and this shows each of the different fire tubes. So this is a top-down view of the boiler, and it has 12 small fire tubes and one large central fire tube. These smaller fire tubes are set on 2 circles, 2 inches and 4 inches from the edge. This one central tube is larger to allow some of the combustion gases to get out and hopefully not build up too much soot inside the firebox. What I'm going to walk through the process of doing is how I took this CAD drawing and laid this all out onto this sheet of steel. So the first thing I did to start is I laid out these 2 circles, here and here. And this one is 2 inches off of the edge, and this one is 4 inches off of the edge. And I did that using the dividers. So after I laid out these 2 circles, I needed to construct this hole pattern. The inner circle was the one to get started on because it's 4 holes spaced at 90-degree increments. I started by laying out this line right here, which is kind of a zero datum. And then what I did is I started to lay out these 4 holes. And so there are 2 ways you could do this. One way would be to use a square and go ahead and construct a line at 90 degrees off of the first line. That's one way to do it, but you don't actually need to use a square to get this done. You can use a set of dividers to divide this into 4 sections. The way this works is you kind of eyeball it and you get it close. So let's say I'm not quite at 90 degrees right there. Then you walk the dividers around, counting the times that you step. So 1, 2, 3, and then 4. You can see here, I didn't make it all the way around back to my first mark. So what I can do now is I can go ahead and adjust this to be a little bit longer and try it again. All right, so we increase the width of the dividers a little bit. 1, 2, 3, 4. And now we're right back to where we started. So what that's done is that's divided this into 4 equal divisions, which is inherently 90 degrees. It's kind of an incremental trial and error process, and that's definitely not the fastest way to do this, but it does work. This is how it was done in the days back before precision measuring instruments were available to every machine shop. I'm going to do that for this outer hole pattern as well as this inner hole pattern. Honestly, I should probably pick up a can of the spray Dicam. This hole's about 2 inches, 230 thousandths. I'm going to make the circles that I draw just a little bit smaller diameter than the hole so I can see them to get this lined up visually. And what I'll do now is I'll set the dividers off of the calipers. Now I can just lay this template down on top and easily line it up with the scribed mark and know that I'm pretty darn accurate. Really, this is probably more accuracy than I even need. What I do need to do is I need to make sure the top and the bottom tube sheets match each other perfectly. I could repeat this process, but that would take the chance of putting a lot of error into this process because there's a lot of places to mess up. Or I could transfer all the center marks from these holes onto the other piece using transfer punches. Transfer punches are a set of punches that are designed to fit snugly into drilled holes, and they have a center punch point that allows them to locate the exact center of the hole that they're inserted into. What I can do here is I can drill holes through all of these, and then I can transfer the marks to the bottom piece using one of these transfer punches. It's probably overkill, but what I'm going to do is I'm going to start with this 11/64 drill bit, and then I'll ream the hole to 3/16, and then I'll use this 3/16 transfer punch. Even though it was an extra step, I'm really glad I drilled the holes undersized and reamed them. It's a perfect fit for the transfer punch. I've got the top and bottom tube sheets clamped together, and now what I'm going to do is transfer the holes with the transfer punch. Before I take these apart, I need to mark them so I can get them in the correct alignment again. I'm going to basically mark a north and a south, and I'll just use that as the orientation of these tube sheets inside the boiler. The marks transferred really well, but they are a little bit hard to see. I marked them with a Sharpie just so I don't get confused. When you're using these transfer punches, you want to strike pretty lightly because you don't want to tear these up. What I'll do is I'll go back and hit these again with a center punch to kind of enlarge that mark and make it easier to see. So when I'm piercing the workpiece, I start with the tip at an angle, and then I slowly tilt it upright as I'm blowing the slag out, like this. If you just go straight in, you'll tear up your nozzles really quick.
Got no class or attributes. Don't know if I'm talking about me or you. Baby, no one gets me like you do. I said loving you is a train wreck waiting to happen.
I'm starting to get everything gathered up to start welding the boiler tubes together. These are the Firetubes right here. I actually cut these a long time ago, back before I even started shooting any video on this project. What I did is I cut these out on an Evolution chop saw, and then I chucked them up in the lathe and beveled the edges and gave them a nice polish where I'm going to be doing the welding. This larger tube here, this is the central Firetube. That is basically acting to get the majority of the combustion gases through the chamber. Hopefully this means that it won't soot up quite as badly as if I had done all small Firetubes. The tube sheets are all cut out, and I made sure that the Firetubes actually fit in the holes. At this point, I'm ready to start fitting this up, and hopefully it's going to start to look like a boiler soon. I have this flipped upside down so I can tack these into place. I'm starting with the bottom tube sheet. I'm going to use the central Firetube as a guide for both of these sheets. So I have it held in place with the magnets, and what I'm going to do now is I'm going to square this up and get it tacked into place. It looks pretty good. I'm sure it'll move a little bit when welding. I've got the central tube tacked, and what I'm going to do next is I'm just going to insert these Firetubes, square them up, and tack them one by one until I get all of these tacked on the bottom. Then I'll flip the whole thing and try to get the top sheet to fit. Now that I have the inner 4 tubes tacked in, I'm going to go ahead and try to fit the top sheet so that everything stays lined up. This is all directional. This is the side that I marked as north before, and I got to make sure that this lines up. I'm going to need to touch up a couple of these holes with the grinder. There we go, all together. So this is what the core of the boiler is going to look like. I'm going to go ahead and get everything tacked up and then flip it and do the other side. While I've got this sitting here on the bench, I figured it was a good idea to talk through exactly how this part of the boiler system works. So this is the core of the boiler. It's composed of these fire tubes and these two tube sheets, top and bottom. The bottom tube sheet is made of some thicker material because this is directly over the firebox. This will be receiving the heat directly from the wood fire below. This section of the boiler will then sit on top of the firebox. These fire tubes are open to the top and bottom, open to the firebox and open to the chimney above. And this allows the hot combustion gases from the wood fire to flow through these tubes and out the chimney. This will heat the water around these tubes and make a much more efficient boiler than just a pot of water sitting on top of a stove. When this is full of water and the heat begins, this here will become a pressure vessel. I'm aiming for this to be pressurized during use to between about 30 and 50 psi. But that also means that this is a pressure vessel. Pressure vessels are dangerous, and pressure vessels require quality welds. The tops of these tube sheets are going to be ground smooth, and all these tack welds will be ground smooth as well. That'll mean that I can weld over them as if they're not even there and get a good solid full penetration weld all the way around every single one of these tubes. Hopefully with all of these tubes fully welded, this should be a very overbuilt system and should hold much more pressure than I intend to actually run. Now, before I ever pressurize this and even think about heating it up, I will pressure test this using a hydraulic pressure tester. It's also going to have a temperature and pressure relief valve just like a domestic water heater. I'm going to take this over to the scale and figure out how much this weighs. I definitely wasn't expecting it to be more than 50 pounds. 59 pounds. That's a lot of steel. I've got the boiler fittings all mocked up here so I can see how it's going to look. All of these holes need to be drilled before I start welding because I don't want any of the swarf or anything like that to build up inside the boiler and not be able to get it out. Alright, so going through the connections one by one. On this side I have the in and out for the hot water circulating loop. Up here on top this will be the fill port. This top outlet is for a temperature and pressure relief valve, and then this bottom outlet will be for the boiler blowdown valve. The reason these are so long is I want to leave myself the option to put some insulation around this boiler someday. This fill port's actually going to be pretty finicky to get laid out and put in the right position. This needs to be lined up perfectly in the curved smoke dome. So I'm going to have to get a little bit creative, and I think what I'm going to do is I'm going to drill the hole in the smoke dome first and make sure it's in the right place, and then somehow transfer that mark, maybe with a paint pen or something, onto the top of the tube sheet so I can get that hole in the right place. I'm going to go ahead and set this fill port at about 2.5 inches away from the outer edge of the boiler. There's my mark, 2.5 inches in, and I use the small square to lay that out. I've got everything visually lined up. That actually worked really well. It's kind of hard to see, but there's definitely a mark there that I can use. Now I've got to get the holes for the rest of the plumbing laid out. What I need to do is I need to divide this into quadrants. I'm going to do that using some of this green vinyl tape. I'm leaving the backing on it so it's not sticky, and I'm just going to go ahead and tape one end of it here with some blue painter's tape. I'm leaving that top part exposed so I can see where the tape begins and ends. And I'm just going to wrap this all the way around, making sure it stays nice and square. And now I can come in here and make a Sharpie mark where it meets. So now to divide this into 4 quadrants, all I need to do is fold this tape in half, making sure it's nice and lined up. Give it a good crease. And do that again, making sure all the ends stay lined up. And now I have creases. So what I can do is I can tape this back on here, starting at that central datum, which is the seam. Making sure to pull this snug and overlap properly. Go ahead and tape it down. So now I can go ahead and make a mark at each of these creases. It's a little hard to see, but after running the vinyl tape around the top and the bottom, I've got Sharpie marks at all 4 cardinal directions here. I'm going to go ahead and draw some lines, because I'll use these for layout of all kinds of things on this boiler. And I'm also going to mark the cardinal direction next to each line. I'm going to start marking over here on the east side. This will have the hot water outflow and the cold water inflow on the hot water circulation loop. I've got it switched over to the west side. We're going to have the temperature and pressure relief valve, and that's also going to be at 2 3/4. And then the harder one to measure is going to be the boiler blowdown outlet down at the bottom. I'm going to talk more about how boilers work and the different parts of the boiler in the next video, but the boiler blowdown needs to be right above the bottom of the boiler. The whole point of that is to drain out any of the sludge and muck that would accumulate at the bottom. And so what I need to do is I need to make sure it sits right above the top of that tube sheet, but doesn't interfere with the welds and doesn't interfere with the position of the tube sheet. Moving on to the south quadrant, there's going to be a dial thermometer mounted on the front so you can see what temperature the boiler is at a glance. And that's going to be set down here at 8 inches. I've got the boiler core all fitted up inside the shell. I went and I hit the top of this with the grinder to make sure all my tacks are ground down flush. The next step will be to come put some tacks to tack the shell to the core and help fill in some of these gaps in my fit up here because it's not quite perfect. So I think what I'm going to do is I'm going to start with welding the shell to the tube sheets, because that way if I have any distortion it shouldn't affect any of these tubes. Down here on the bottom, I'm going to have one big fillet weld that goes all the way around here. The reason I did that instead of an outside corner weld like the top is this is going to need to have a butt weld that attaches it to the firebox. I didn't want those 2 welds to be on top of each other, so hopefully this will help keep things separated and make sure that there's not any issues when I go to weld it together. On the left side I have about a 1/4 inch gap, and on the right side there's no gap. So what I'm going to do is I'm going to put all the tacks onto the left side, and hopefully that'll pull it center and make it so that I have a fairly even gap to fill up all the way around. What I'm going to try to do is keep the majority of the heat on this 1/4 inch plate, and then just as I go around this fillet, wash it up onto this thinner 1/8 inch material that makes up the shell. Not the prettiest weld in the world, but I do seem to have pretty good penetration all the way around. I've got a couple of spots that I'll definitely check when I do the leak testing on here. I probably should have ground out my tacks or feathered them in better. I'm going to flip it over and start working on the outside corner weld. I've got the outside corner weld all done. Went okay. It was a little bit easier to do than the fillet down below. And I started working on some of these tubes. And I have to say, after doing 3 of these, I have a lot more respect for the guys that do this kind of work day in and day out. Honestly, I just don't have enough practice to do clean, good-looking welds on something like this. I'm all done with the top, and I gotta say, I'm definitely not gonna quit my day job. I got it all done, and I'm actually pretty pleased. Doesn't look pretty, but I do think everything has good penetration and will hold, and hopefully it'll pass the pressure and leak test. This is a hot tub. It's not a life safety device, it's not a steam boiler, it's not a nuclear power plant. It doesn't have to be perfect, and really it's only going to operate at 30 psi. So I think all these welds are going to be perfectly fine for that, and I'm looking forward to finishing up the rest of this project. Well, I hope y'all enjoy getting to see this boiler come together, because I know I did. It's been a long time coming, but this project's finally starting to move along, so I should have more coming up soon. If you want to see more of this project and some of the other things I do around the shop, don't forget to subscribe. Thanks for watching.